a problem on the board? Let's see. What did you paint, Ziggy? Anything?
Boxes.
Yeah. Okay. Zadie painted 18 boxes. This is 3 times as many as Smith. How many boxes did Smith paint? What is the question? Make sure that you don't raise your hand until I've said the question. This is just indicating you can raise your hand. What is the question in this problem? Zari.
How many boxes did Smith paint?
How many boxes did Smith paint? Which word in our question tells us the unit our answer will be in? Aaron? Boxes. How do you know?
Because the word that comes after how many is
Good. Boxes is the unit our answer will be in because it comes after the words how many. Okay, so now we know we're looking for boxes. Do we have each in the problem? So are we looking for another object to add, subtract, multiply, divide by? No. Let's read it again. Zadie painted 18 boxes. Well, I see, what's important in that question, in that sentence? Victoria,
They painted 18 boxes.
do I need to know who it was and what she did with them
No.
to solve the problem? No, I just need to know what?
18 boxes.
18 boxes, because there's our unit that I know I'm looking for, and there's a number. I've got 18, which represents the number of boxes. This is 3 times as many as Smith. I have a number, but do I have any object or anything like that in this sentence? Carla?
No.
No, but what word does tell me, hey, this number's important? Or what words tell me, hey, this number's important?
This is.
Do those tell me that the number is important? Does this is tell me anything about this number 3?
No.
So which words are important that tell me what to do with this 3?
Times as many.
Good. 3 times as many. So this means we're doing one of those comparison math multiplication problems where Zadie has some and we're comparing it to the number that Smith has to figure out how many Smith has. What does this mean? What does this mean? Aaron?
It means that you're doing a division problem.
Okay. But this refers to what number? This one or this one? Huh?
Number 18.
18. We're saying this as in the 18 boxes, so we can replace this with 18 boxes. 18 boxes is 3 times as many as Smith's. So, who can tell me, what does this equation look like? What does this equation look like? It does tell me, does it tell me, Cullen, does it tell me I'm going to end up with a larger number of boxes that Smith has or a smaller number of boxes? Since this refers to 18, and 18 is 3 times as many, are we going to end up with Smith having a larger number of boxes than Zadie or a smaller number of boxes?
A smaller
So which which operation do we have to do?
division.
Division. So we know we have to do division because this tells us 18 boxes is 3 times as many. If 18 is 3 times as many, that means Smith has less. The operation that tells us we're going to do less when we have the word times or each is division. So now, Colin, I have 2 numbers. Which one has to go first in division?
18.
Why?
Because it is the bigger number.
And in division, which number always has to come first?
The bigger number.
Just like subtraction. Good. That means my only other number is 3. Now 18 divided by 3. I may not know that yet, so what can I use? What can I use? If I don't know how to do 18 divided by 3, what can I use? Zari?
Multiplication.
Related multiplication fact. So Zari, what would the related multiplication fact be? 3, which one would I take? 18 or 3? Which one would be one of my factors? Would 18 be a factor or the product in my related multiplication fact?
The product.
The product. Which means 3 would be a factor. Now, is this a lot easier to solve? Because we know this is a basic fact, right, Zari?
Yes.
3 times what equals 18?
6.
6. So that means 18 divided by 3 has to equal what, Zari?
6.
So how many boxes did Smith paint?
6 boxes.
Very good. So does everybody see? That's what we did yesterday. We might see these again today. However, what your math book did is they skipped what you remember in example 1 yesterday, they skipped this division step. But we know that's what it has to come first because that's the information we know, right? But to solve it, since we may not know this yet, even though you should all know it because it's just a basic fact for division, then you can solve it using the related multiplication fact. 18 divided by 3. Well, 3 times what equals 18? We know it's 6, so that means 18 divided by 3 equals 6. Okay, helper number 2. Please sanitize, turn on the projector, sanitize. Even though I'm right here, I can go ahead and erase because I've already got the math book already. And you can open your math book to page 153. Smith, can you tilt, if possible, can you tilt your camera down a little? There you go, perfect. Yes, Helen.
Is there a shadow right there, or is it like a leaf?
Right here?
No, it's like under the thing. Under the silver part. Is that a shadow?
Or this.
The
Or this.
green thing under the silver.
What? Oh, right here?
Yeah.
It's old paint.
Ah.
Because behind this is a chalkboard. Behind, I think all of these is a chalkboard. Your grandpa Smith probably helped put these up at some point many years ago. Okay. Now, let's look at these sentences under the title. I'm going to read them because they do have some difficult words in them, and I want you to make sure that you hear them correctly the first time. Let me put my face on. Okay. So pay close attention. Additive comparisons use addition or subtraction to compare. So that means these comparison problems where we don't necessarily have more than one object, we have one object and then we're comparing the amount one person, like Zadie has, to the amount another person has, like Smith, to solve, that happens in addition too. Addition and subtraction. Multiplicative comparisons use multiplication or division to compare. So those are the types of problems that we worked with yesterday. These multiplicative comparisons. So if you see an additive comparison, like the words how much more, how many more, how much less, that means you will be adding or subtracting. If you see the words how much more, how many more, how much less in a problem, you will be adding or subtracting. You will not be multiplying or dividing. So if you read a word problem and you see how much more and you try to multiply or divide, are you going to be correct? Nope. Now, multiplicative comparisons, if you see how many times more, underline that times, or how many times greater, if you see the word times, you will not be adding or subtracting. Now, I know when we say multiplication, we say 8 times 3. Just because you see times, does that necessarily mean you will be multiplying? No, because we've seen that yesterday. We saw where we had times, and in our problem today we had times, but really the equation was division. But if you see the word times, it means you will not be adding or subtracting. If you see the word times between how many and more or how many and greater, will you be adding or subtracting? No. You will be multiplying or dividing. If you, everybody listen, if you see times between how many and more or how many and greater, you will be multiplying or dividing. If you see something like this, a number and then times, that doesn't necessarily mean that you are going to be multiplying or dividing, because the times has to be after the words how many and before the words more or greater. Because if I said this problem, Victoria jumped off the diving board 6 times. Aaron jumped off the diving board 3 times. How many times did they jump in all? Are we going to multiply or divide? Zadie?
No.
No. Because I said how many times did they jump in all, but did I say how many times more or how many times greater?
No.
No. So that means times is just the unit. 6 plus 3 is 9. My unit is times. They jumped 9 times in all. So make sure that you're looking for the word more or greater, or even sometimes less, after times. Otherwise, it's just the unit. Okay? Does everybody understand that? If you do not see more or greater after the word times in how many times, that means times is just the unit. It's not a multiplicative comparison. Okay. So if you see, again, listen, how much more, how many more, how much less, you're doing what operation? Cullen?
Adding or subtracting.
Adding or subtraction. If you see how many times more, how many times greater, what are you doing? Michaela? Multiplying or dividing. So if you see times before more, greater, or less, you are multiplying or dividing. If you do not see times before more, less, greater, whatever, you are adding or subtracting. So let's look at some examples. Okay, everybody, finger or pencil on example 1. When I see everybody's finger or pencil on example 1, I will continue. Zari, can you move your camera down a little bit? It was down earlier. There you go, perfect. Okay, finger or pencil on example 1. Read in your head while I read out loud. Brian has been to a water park 4 times. Sarah has been to the water park 3 times as many times as Brian. How many times has Sarah been to the water park? Well, the question is, how many times has Sarah been to the water park? Now, I know this question says how many times and doesn't have more or less. But we see times as many in the problem. So even though this question doesn't say how many times more or how many times greater, does that mean we're doing addition or subtraction? No, because sometimes you have to look at the rest of the problem too. This is why this math book sometimes annoys me. Because it teaches you one thing and then it uses an example that just confuses you. So even though this question says how many times has Sarah been to the water park without more or less or greater after, something else in the problem tells us we have to multiply or divide. So let's look first. Let's find the unit that the answer will be in. I see the words how many. The word times comes after. So this is the answer unit. I don't have each in my question. Did I have each anywhere else in the problem? There's no each in my question. Is there an each anywhere else in my problem? You can show me. Some of you are just staring at me. No. So do I have 2 objects? Am I looking for 2 separate units to set up my problem? No, I'm not. That means I'm looking for a statement like times as many or times more, like what we did yesterday. So let's read the question again. We're going to find a number that represents times, and then we're going to see what number comes before times as many, times more, whatever. Brian has been to a water park 4 times. There's our first number. Times is our unit. We have a number right before, so that means 4 is the first part of our problem. Sarah has been to the water park 3 times as many times as Brian. So here we have 3, and then we have times as many. That means my other number has to be 3. But do I have the words, this is 3 times as many as blank? So am I doing multiplication or division? Do I have this is 3 times as many? Michaela? No. So am I doing multiplication or division? Multiplication, because Brian's been to the park how many times?
4.
Michaela? 4 times. Is Sarah going to have gone more or less than Brian if Sarah has been 3 times as many times? More. What operation tells us we are going to end up with more? Multiplication or division? Multiplication. So we have Brian's 4 times. We know Sarah has been 3 times as many. So we're going to take Brian's times. We're going to multiply it by 3 to get our unknown, which is the number of times Sarah has been to the water park. Read this sentence, write an equation to find the unknown, because that's what you have to do every time you have a word problem, right? You can use a letter or a variable to represent the unknown. Sarah's name starts with S, so they just chose S, because S represents the number of times Sarah has been to the water park. Now we can draw a picture. When we draw a picture, what do we start with? This says we can do either one. That is true. But the easiest way is to figure out what do you know 100%. In this problem, what do you know is exactly true? Zari?
Brian has been to the water park 4 times.
Good. So let's model Brian's 4 times using counters. Remember, we're not going to do grids because sometimes you guys go too quick and you end up with way too many boxes. So let's do counters because they're easier to make sure you have exactly the right amount. So let's model Brian's 4 times at the water park. 1, 2, 3, 4. I'm not going to label it as Brian because I'm going to use it as part of my model. How many times more has Sarah been than Brian? How many times more has Sarah been to the water park than Brian? Kingston? 3. Sit up, please. So how many times am I going to repeat Brian's times to show Sarah's? 3. So here's my first group, my second group of 4, and my third group of 4. How many counters do I have, Kingston? 12. So that means 4 times 3 equals what? 12. First we had S. Now we know S equals 12 because 4 times 3, if we take 4 and we repeat it 1, 2, 3 times, we get 12. So Sarah has been to the water park, Zadie,
12 times.
12 times. Because 4 times 3 equals 12 times. Okay, how does everybody feel about that? Are you seeing that word problems, it's just about finding certain words. It's a pattern. You're usually finding the same types of words every time to set up your problem. So just because I'm not walking you through it, well, you can look back and see, okay, what words did they use here? Well, I'm going to look for those same words in my problem. Okay, let's go ahead and look at example 2. Helper number 1, please sanitize, erase. Okay, so everybody, finger or pencil on example 2. Okay, read in your head while I read out loud. Jess has 18 baseball cards. She has 6 times as many baseball cards as Max. How many baseball cards does Max have? Well, we see the question, how many baseball cards does Max have? Again, we don't see how many times more or how many times less, but that doesn't necessarily mean that we are adding or subtracting because we might have we might have the words that tell us what operations to do somewhere else in the problem. But let's look. Baseball cards comes after how many? So I know that is my answer unit, or the unit my answer will be in. So I know my answer is going to be this many baseball cards. Do I have the word each in my question? You can show me. Do I have the word each in my question? Do I have the word each anywhere else in my problem? So am I looking for another object to multiply, divide, add, or subtract? No. So I'm probably looking for something like times as many or times more. Let's find out. Let's read again. Jess has 18 baseball cards. Well, I see my answer unit, baseball cards. I see a number before it, so that means my first number is, or one of my first important piece of information is 18 baseball cards. The next sentence says she has 6 times as many baseball cards as Max. Well, I see the words times as many, and I see 6 before it, so I know 6 is my other important number. Now I have to figure out, okay? Is Max going to end up having a bigger or smaller number than Jess? Because that's going to tell me what operation I'm doing. Well, I know my question says Jess has 18 baseball cards. She has 6 times as many baseball cards as Max. Again, that means the same thing as this is. So we can replace she has with 18 baseball cards is. So 18 baseball cards is 6 times as many as what Max has. So is Max going to end up with more than 18 baseball cards or less than 18 baseball cards? Carla?
Less.
Less, because it's saying 18 is 6 times as many as this number. That means 18 is 6 times more than Max's number. If 18 is 6 times more, that means 18 is bigger than what Max has. So let's write an equation, but even though they have multiplication, we know what type of problem is this actually. What type of problem is this actually if what the information we have is that Jess has more than Max? Aaron? Division. So let's write our division problem first. We have 18 and 6. We know the bigger number has to come first in division. So our division problem looks like 18 baseball cards divided by the only other number we have, which is 6, equals Max's baseball cards. Now this is where we can use a related multiplication fact. Well, here they just went ahead and said our variable times blank equals blank. Well, in multiplication, is the bigger number going to be a factor or the product? Cullen?
It's going to be the product.
So where does 18 go? In this blank after the multiplication sign or in this blank after the equal sign?
After the equal sign.
After the equal sign.
Third.
Which means our other blank, we put our only other number. M times 6 equals 18. That's our related multiplication fact. Since M times 6 equals 18, you know that 18 divided by 6 equals M. So we can use a fact family, but we're going to go ahead and model what this looks like. We could use a fact family, and if you know your basic facts, you don't have to do a model. But we're going to go ahead and draw a model just so we can see what this looks like, because it always helps to see what it looks like. Then it helps you to see why the answer is what it is. So we're going to draw 6 equal groups of squares. There's going to be a total of 18 squares. So let's go ahead and start with our 18 squares. Then we can make 6 equal groups. 1, 2, 3. Remember, we're going to do separate squares, not grids, because you guys go too fast to do grids. So 1, 2, 3, 4, 5, 6. I know I need equal groups of 6, so would it help to go ahead and start another column here maybe, or another row? Probably. 1, 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I need to figure out my 6 equal groups. Well, I already know I wanted to make rows of 6. So that means each of these rows has 6 in it because I made sure that I had 6 because I knew 6 was going to be important. So let's circle 6 at a time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Do I have any more groups of 6 to circle? Nope. So, there are how many squares in each group? Well, we did this backwards, but oh well. Okay, Backtrack. Sorry. Erase.
Oh.
This is where your good eraser comes in. This is where your good eraser comes in handy. Sorry. Backtrack, pretend I didn't say anything. We should have done our groups first and then put 18 in them. So we're going to draw our circles first. We're going to draw 6 circles, 6 big circles, not 6 little counter circles, but 6 big circles to represent our equal groups. 1, 2, 3, 4, 5, 6. Make sure they're big enough that you can fit counters or squares inside of them. Sorry guys, I hope I'm not confusing you. Just ignore what I said. We're starting with our 6 equal groups, which means my groups are what I fit things inside of. So make sure that your groups are big so that you can fit counters inside of them. Okay, I'm just walking around to make sure that you are with me. Okay, now we're going to start filling them with squares. How many total squares representing the baseball cards do I need? Carla?
18.
18. Now, am I going to do this? Don't do what I'm doing right now. Am I going to do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, can't fit anymore. 11, 12, 13, 14, 15, 16, 17, 18. Oh, I'm done. Is that what I'm going to do?
No.
Because when I get to there are blank squares in each group, well, do I have one number to put there? No, I'd say, well, there's 11 squares here, and there's 9 squares there. Oops, 10 squares here. I don't know, whatever I did. 9 squares, whatever. And then there's 0 squares in the rest of them. Would that be my answer? No, I have to put them in equally. Which means when I am doing this, I'm going to go one at a time until I put one in each group. Then I'm going to go back around and do it again. 1, so do this. 2, 3, 4, 5, 6. I've put one in each group, so let's go back around again. 7, 8, 9, 10, 11, 12. I've put another in each group, so let's go back around again. 13, 14, 15, 16, 17, 18. Do I keep drawing squares? No, I got to my 18 squares. I've got my 6 groups. So that means I'm dividing those 18 squares into 6 equal groups to get the number in each group. How many squares are in each group? Michaela, let's count to make sure. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So yes, there are 3 squares in each group, which means that M equals 3, because if I take 18 and I break it into 6 groups, I get 3 in each group. So M equals 3. So Max has, Zari.
So Max has 3 baseball cards.
Good. Because I took Max's 3 baseball cards, I repeated it 6 times to get Jess's 18 baseball cards. Okay. Everybody feel okay about that? It's just about looking for patterns, looking for certain words that we see every time, looking for words in certain places. Like this word after how many changes every time, right? But it always comes after what words? The word after how many always changes, but it always comes after what word or words? Carla? Sorry, I don't know what you're doing right now.
Time as many.
Carla, please listen to the question. The word after how many always changes, but we always have a word for objects after what word or words? Victoria? Listen to my question again. We always have a different word or words after how many. But we always have a word meaning objects after what word or words? Carla.
How many?
How many? Or how many more? Or how much more? It's not always the same word, but we always have something. So we always know that's going to be the unit our answer is in. We don't always have the same number before whatever that unit is, but we know we're looking for the number before that unit. We usually have times as many or times more, but the number before it changes. But do we always end up using that number? We don't? Has there been a time where we did not use the number before times as many or times more? Yesterday or today? Aaron? No. So even though the number before times as many or times more changes, is it still important no matter what number it is? Yes. But you guys, you just want to get finished. You've got to look for patterns. You've got to look for patterns. That will help you. Instead of just going in and picking out random information so that you can be done with the problem, move on to the next one, and then get finished, look for the patterns. Look for the word after how many. Look for the number before times as many. Look for the number before your unit. Find your unit first. So then you know exactly what number you're looking for, a number before that unit. Some of you just want to get fast. You learned some very bad habits last year, and they are not helping you. Okay, helper number 2. Please sanitize, erase, sanitize. Everybody look at number 1 in the guided practice. We're doing the same thing. We're reading the problem, looking for the question, looking for those patterns so that we know what words and numbers we're looking for. So number 1, read it in your head while I read out loud. You think of one? What do you have? Make sure that you're paying more attention to math. Number 1, Sue has 3 times as many beads as Joe. I see some important words, but I'm not going to box them yet because I want to make sure. Joe has 8 beads. How many beads does Sue have? Write an equation to find the unknown number. Use a variable for the unknown. Oh, so that means we have to use variables and equations. We might not have multi-step, but we still need an equation with a variable. So now we know the question is, how many beads does Sue have? Aaron, where should we look first? What pattern can you see? What words do you always see in a question? What word, Aaron, what words do you always see starting a question? What words? Look at the question, please. Like I just said, what words are you always seeing in these questions since the beginning of this math class and since the beginning of this year? What words does the question always start with? Cullen.
How many?
How many? Aaron, do you see that? Are you looking at the question? Did you underline it with me? So what words does the question always start with? How many? We always know that what comes after how many in all of these problems. What always comes after how many, Aaron? The unit that our answer will be in. Is that the case here? Yes. So what unit is our answer going to be in? Beads. Do we see each in the question, Aaron?
No.
Do we see each anywhere else in the problem?
No.
So are we looking for a number to represent a different object other than beads? No. So that probably means we're going to have some other important words that we see a lot in these questions. So let's start at the beginning. Sue has 3 times as many beads as Joe. Ooh, usually at the beginning, we see that someone has blank beads. Do we see that in this question?
No.
But we do see something else that we see a lot. What words do we see that we've seen a lot in these lessons today and yesterday?
Times as many.
Times as many. So we know if there's a number before that, is it important?
Yes.
Yes. So what's the first piece of important the first piece of important information in this problem?
3 times
3 times
as many.
as many. So we know Sue's is 3 times as many as whatever Joe has. The next sentence says Joe has 8 beads. Oh, well now what do we see there? B. Do we have a number before that unit?
Yes.
If we have a number before the unit, is that important information?
Yes.
So what's our next piece of important information?
8 beads.
8 beads. So we know the numbers in our equation are going to be 8 and 3. Now we have to figure out what to do. If Joe has 8 beads and Sue has 3 times as many as Joe, is Sue going to have more or less than Joe? More, because that means whatever Sue has is 3 times as many as 8, which means it's 3 times more than 8. So we know times tells us we're doing multiplication or division. Since Sue's going to end up with more, which operation tells us that our answer is going to be bigger than what we already had? Multiplication. So we're taking Joe's 8 beads and we're repeating them 3 times, which looks like what? The 3 times the 8 what? Beads. Equals however many Sue has, which is B. They use B for beads. So we have 3 times 8 equals B. Now we need to figure out B equals what? Well, this is a basic fact. 3 times 8 equals what? This is why you need to know your basic facts. 24. So Sue has 24 beads. This is why you need to know your basic facts, because we're not going to have time for you to count up every time. Okay. Trying to think of what I want to do. We're going to do one more problem from the independent practice, and then after music, you'll have time to work on the independent practice. Okay, so quickly, helper number 1, please sanitize, erase, sanitize. Okay, so the directions for number 4 and 5 say algebra. Write an equation to find the unknown number. Use a variable for the unknown. So that means you need an equation and a variable. So let's look at number 4. Read it in your head while I read it out loud. It is very important that you're paying close attention. Wendy has dance classes 2 days a week. James has dance class 5 times a week. How many more times a week does James have dance class than Wendy? Sorry. So what's our question? Actually, I'm going to fix it. Victoria, what's our question in this problem?
How many more times a week does James have dance class than Wendy?
Ooh, I see that how many more in times. But where's times? Is it between how many and more? Or is it after how many more?
How many more is
So are we multiplying or dividing, or is times just our unit? Where does the times have to be for it to be multiplication or division?
Times is just
What?
times is just a unit.
Well, where does times have to be for it to mean multiplication or division? Between what? Between how many and more. So it's not how many times more, because times comes after how many more. So that means times is our unit. Now we see how many more, which means we're doing what? How many more means we're doing what operation? We don't see times, so are we doing multiplication or division, Victoria? And if we're doing how many more, this is something we did before, it means we're doing what operation? Subtraction, because when we see how many more, it means subtract. We're trying to find the difference between two numbers. So now we know we're looking for our unit of times. We're looking for numbers to represent times. We're doing subtraction. So that means we're going to find whatever numbers come before the unit times, and we're going to subtract them. So let's read this sentence again. Wendy has dance class 2 days a week. Uh-oh, I don't see times. But I know what? Does days mean the same thing as times? Is day a unit of time? Is day a unit of time? Zari. Oh, she's frozen. Smith.
Yes.
Yes.
It is a unit of time.
Because we can measure how far away something is or how long ago something was by saying it was 6 days ago. So, just because we don't have times, we know days is a unit of time. So that means what's our first piece of important information? 2 days. Second sentence, James has dance class 5 times a week. Oh, now we do have times. But does it mean the same thing as days? Yes. So we have 2 days and 5 times. What does our equation look like? We're doing subtraction. 5 minus 2 equals, what variable would you like to use? We are using letters now. T for the times a week. We're not done though, because now we have to solve t equals what? Well, why didn't you do 2 minus 5? 2 came first in the problem.
Because if you have 10, you cannot subtract 5, and you always have to put the bigger number.
Good, because in subtraction, just like division, you have to put the bigger number first. So even though 2 came first in the problem, well, we can't say 2 minus 5.
You don't have that much.
You don't have 5 to give away. So we have 5 minus 2 equals t. Now we have to figure out what t equals. Do we have to do that whole equation with the carrots and bringing down and everything? We only have one step, right? So 5 minus 2 equals t. That means t equals 3 what? 3 times. If you haven't noticed, you are losing points for not doing units on homework. So make sure 5 minus 2 equals t. T equals 3 times. So that means James has dance class 3 times more. 3 times more a week than Wendy. James has dance class 3 more times a week than Wendy. So pay attention. Are you trying to do addition or subtraction or multiplication or division? Bless you. So pay attention, because some of these problems are multiplication and division. Some are adding and subtracting. So pay close attention so that you can figure it out. Remember, if you see how many more or how much more, you're usually going to be subtracting. If you see how many times more, how many times, or how many times more, well then you'd be multiplying or dividing. Okay, so go ahead and close your math book.